Well, hello everybody, and welcome again to another OpenShift Commons briefing. This one from an OpenShift Commons member, OpsMx, who are amazing folks in the Spinnaker community, and they're going to talk about continuous deployment on OpenShift with Spinnaker, which I've been looking forward to for quite some time. I'm going to let the two of them, Gopinath and Balajay, introduce themselves, and you can ask questions in the chat, and we'll have live Q&A at the end. So take it away.
Right, thank you, Diane. My name is Balaji, and we will, and I have with me Gopinath. We'll talk about how to use Spinnaker basically to do continuous deployment and delivery with in OpenShift environments. Let's go to the next slide, please. So again, my name is Balaji, and I'm a VP of Products at OpsMx, which is a startup based out of Silicon Valley, focused on continuous delivery and intelligence control on continuous delivery. And Gopinath, who's my co-presenter here, is our CTO of the company. So we will go through the current, sort of the little bit of a background about continuous delivery and deployments, because that's something we want to get the same language across the board, so everybody is on sync. And then we'll talk about the current is today, and how some of there's some drawbacks or some of the challenges there, and how Spinnaker could be something you could use to not only do deployments, but to do full continuous delivery with OpenShift across other hybrid cloud or public cloud settings you have, environments you have, maybe AWS, you have native Kubernetes or GCP, etc. So Spinnaker is a tool that allows you to deploy across multiple clouds, and this is something a lot of large customers have adopted. We will introduce the Spinnaker itself and go through the details around the various features and why a lot of people like Spinnaker, and we'll do a demo. We'll have a couple of slides on what is Enterprise Spinnaker is, also some of the requirements of Enterprise Spinnaker, and that's where sort of maybe our little marketing, a little our messaging around like what we provide value add to the community around enterprise use of Spinnaker itself. All right, go next slide. So to level set, I think the enterprises are, they have done the CI part, the continuous integration part fairly well. They are able to now automate from code to do continuous integration through Jenkins and build an artifact and be able to then deploy into test, deploy into production, staging and production. But most of the part of deploying into staging or deploying into production is done through manual scripts. And that's one part of the problem. Another part of the problem is that there's a lot of verification that needs to happen, maybe for compliance, maybe for just the quality of the release, whether the release actually works. A lot of these things are done in a manual fashion or some sort of a scripting, but it is very custom scripting. So obviously applications change over time, so it's difficult to keep track of all of that. So it's a big challenge from going from an artifact to deploying, automating the rest of the pipeline. So continuous delivery provides that end-to-end from code to deploy, production deploy, and even monitoring in production, that full automation. If you look at many large customers that we work with, they are increasingly needing to go to obviously a high velocity release process, right? Compared to the past years of deploying every couple of months or month or even week, for example. They want to do more quicker than that. And obviously that need came about because of microservices, the way that there are too many, now that applications are kind of split into a lot of microservices, so you're actually doing updates much quicker, and you want to be able to update them within an hour, basically. So there's a need to do faster, and obviously when you want to do faster, you want to automate it because there's no way to manually test and verify all of these things, and that's where the Spinnaker comes in as well. Some of the things that we OpsMx is doing is also comes in terms of verification of these releases. And this is sort of the problem that I think that the previous slide was talking about, where most enterprises actually are complaining about that. right? So in terms of requirements of the CD, the next generation CD, so what does enterprise really want from a requirement perspective? Previously we saw about lack of automation. So that's obviously one of them is the automation releases. And the other aspect is the ability to do program where people want to do DevOps practices and they want to be able to program the pipeline creation, the pipeline modification, et cetera, and be able to reuse them in a programmable fashion. And that's a huge part of the requirements of the next generation continuous deployment tools. The other aspect I talked about earlier is the multi-cloud. You have OpenShift obviously in this audience, but you obviously have, I'm pretty sure you have, either AWS or OpenStack. There are other, maybe even bare metal or vSphere. How do you deploy across all of these things? You don't want to have, 5 different tools to deploy into 5 different environments. And then you want to be able to deploy safely. We talked about how fast you want to do it, but then fast is going to get you in trouble if you don't do it in a safe fashion. So you want to be able to do a safe deployment strategies like Canary, Blue Green, and rolling update automatically built in, and also be able to automatically roll back. That is a big part of it. I mean, you would have a mistake or you would release a bad version into production, and you want to be able to roll back quickly not only the actual artifact, but also any configuration changes that goes along with it. And you want to be able to do automated verification, and that's sort of where it's more data-driven now. If you look at Spinnaker, they introduced a feature called Kayanta, which is basically automated canary analysis. And we will spend a little bit more time around that in the later part of the things. And the other part that I think people in this audience probably appreciate is the open source mandate that's enterprises are requiring for any tools, anything in the IT industry, right? I want to be able to have an open source tool so that I don't have to be vendor locked in, and that's something Spinnaker provides very well. So with that, I think I'll pass on over to Gopi, who's going to explain to you obviously OpenShift deployments, current strategies, and what Spinnaker does for you, and then I'll come back in the later part of the session. Gopi.
Thank you, Balaji. Greetings, everyone. So Balaji gave a brief motivation for the continuous delivery and the deployments. Essentially, you want to have the incremental deliveries with feedback all the way from operations to developers to provide a continuous improvement in the processes and reduce the friction between delivering from one stage to another. So that's a kind of goal to reduce the risk in delivery at high speed. Right? OpenShift is a great platform. It is cloud native. It supports Kubernetes natively. It's multi-tenant. You can run this on multiple infrastructures, AWS, GCP, on-prem. That's one of the things that enterprises love about OpenShift. And it provides entire feature set of Kubernetes with added benefits of few things that are built in on top of it, including the deployments and routes and things like that. And they are part of the CNCF. Any advances that are going on, like service mesh integrations, they're all being built in. So it's a great platform that's very good for microservices and incremental delivery. So for people just to refresh what is provided by OpenShift and in terms of added benefits on top of Kubernetes. Here you can see that all the blue ones are Kubernetes that come as part of it, and the rest of them are the features that are provided by OpenShift environment. And it comes with the default SDN. I think it's a similar thing that comes from OpenStack. Routes, which are provide this ingress is provided by the Kubernetes, but the routes from OpenShift were implemented much before ingress, and it's much more stable and also provides the traffic shaping between different deployments that we want. And it also provides additional deployment configurations, particularly with integration with CI tools and built-in image repository. So essentially, OpenShift also is providing additional features for continuous deployments, right, and in the delivery. So the deployment strategies, since we are mostly focused on deployments today in delivery, strategies generally are this rolling update, which essentially replaces one instance at a time in the target deployment. And once it's ready, then you go to the next one. This is sort of what is provided by Kubernetes also. There are readiness probes with additional pre and post checks that can be done. And there is a blue-green. Blue-green is the strategy in which you bring up a new cluster, newer version of the cluster, and start using it. If there is something wrong, you have the ability to switch back to the previous version of the cluster to reduce the risk of the amount of downtime that you would have with the failures that with the new version. A/B deployment is more for the API compatible deployments where you have both V1 and V2, version 1 and version 2 running simultaneously with the traffic shaping that's going on. All of these can be done through custom scripting with native Kubernetes. And essentially that is what is exposed through OpenShift, with OpenShift also providing some template-based systems that allow somewhat simpler deployment without having to know the entire YAML structure for, say, replica sets or deployments that are provided by Kubernetes. So to give a quick example on how the blue-green can be achieved through OpenShift environment, let's say we have a version 1 of a service that is running in the target environment. You would bring up a version 2 with a new app example version 2 and give it a new name. Essentially, it's a label that we are assigning to the newer version that is coming in. And for a service, as a selector, just to refresh for people who are not very clear on the terms, the service is more like a load balancer or a firewall that's put in front of the pods, which can be one or more containers that expose certain features from that pod. In these services in Kubernetes, they work by using selectors. Each of these pods can have the labels that are assigned to them. And in a service that you specify that these are the labels that I want to send traffic to. And that is how it works. So here, what it's doing is for the service, it's updating the name of the selector for which it needs to send traffic to the example blue. So the previous version did not have the label example blue. Now all the traffic for this service that is incoming into the cluster will be sent to the example blue. But the previous instance is still running. Now you want to go and clean up that instance, keep it around, reduce the number of instances of pods to 0, but have the replica set on. So if something goes wrong with the newer version, you can go back and increase the number of pods in the previous version and delete the newer one to achieve this blue-green reduced rollback. But this looks simple enough, but in reality, this requires a lot more scripting to actually get it automated and working in production environments. For example, if you deploy the version 2, this is a declarative approach. You tell Kubernetes or OpenShift, bring up three pods for my version 2. And that's it. The OC comes back and says success. Now you have to wait until the readiness of all of these is confirmed before you switch over to the newer versions with the selector spec. So all of that needs to go in, and you have to make sure all the scripting waiting is done correctly. And if there is some failures, you don't want to go forward with the deployment. And all of that scripting now becomes part of the deployment. So essentially, although there are significant deployment things that are provided by OpenShift environment because of the microservices, some are much easier than what it used to be native platforms or bare metal platforms. You get away from the DLL health and incremental approach of having a container that's immutable, that's deployed, that allows us to roll back easily. But there's still, the strategies require additional scripting that needs to happen. Either you want to do blue-green or AB. There's additional scripting that needs to happen for those. And even with the pipeline integrations, one of the things that we want with continuous delivery is shift left continuous feedback from operations to developers on the improvements that can happen in the pipeline, reduce the risk in handover. All of that conditional deployment strategies are not easy to build in. All that requires a lot of scripting again. Like Balaji was mentioning, enterprises now have multiple cloud environments. Some of them work with Azure and AWS, GCP, and also have OpenShift environments in-house. Some of them even have OpenStack. So to manage the applications that are across resilient with multiple cloud environments, you need to have a consistent delivery mechanism, consistent view of your application, which parts of the system are working and which ones are have a high availability, fallback mechanisms. All of that needs to come into a single view for application developers to the operations of those applications. And that consistent view is critical for enterprises to manage their applications with large number of services. With the microservices now, they're exploding. Each application has 20, 30 microservices. This management becomes much harder. Policy controls is another one. So enterprises have these policies saying some of these components need to go through, say, SOX compliance, or some static rules only at certain level they can go to some environment. Developers in their testing, they want to get around these controls and test in those environments without having through certain number of checks that needs to be done for functionality, but use the same kind of artifacts once they are tested, pass through the pipelines to go to staging or test environments. So all of that needs to be built in a consistent view. We talked about blue-green, and Balaji also mentioned about canary. This is one of the strategies where you want to be able to do automated verification of the artifacts that you're deploying, make sure they are consistent with expectations on performance and availability with previous version. So let's say we are deploying version 2, what the strategy is to deploy 5% of the traffic or 10% of the traffic to the newer version, and make sure the performance is consistent with the existing versions or better. And only then you go ahead and you do this in an automated way, right? This is commonly done in manual, in the sense when you deploy a new version, the operations team would go and check if the latencies are good, memory utilization is within the range, and then they move forward. So this Spinnaker provides this automated canary that you can use it out of the box. DevOps processes, shift left is one of the critical things really to improve the process continuously. And with all this declarative approach YAMLs, and you have too many YAMLs. For each of the service, you have one YAML you're managing for those applications, and different environment that you're deploying for the development or in production, you construct a different YAML because you want to go through different checks. All of that is exploding, and even with the templates, Helm charts, there's still a lot of scripting that goes around. All of that is better managed if you have a system to have pipelines end-to-end that support it. And also, it cannot be completely declarative because of the policy checks that are involved. So you need to be able to combine this imperative and declarative sections to provide this. So essentially, you want to have a simpler process to deploy code to production. And at the same time, you want to be able to manage these pipelines in an enterprise with the flexibility of self-service of the developers without having to do a lot of training. So that's essentially what Spinnaker brings to the table. It is built ground up with the DevOps principles in mind. Right? It supports a scale. Netflix has been using it for a few years now. It supports the multi-cloud deployments, and it has built-in automated safe releases, ability to roll back this canary, blue, green rolling updates. They're all built in, and they're consistent across multiple cloud environments. If you're deploying to OpenShift environment, the terminology and how you construct the pipelines is similar to how you would deploy for an AWS. It supports this templates and built-in RBAC for enterprises to deploy to their development environments and production environments. It's a very active community. The Slack channel has thousands of people and hundreds of developers supporting Spinnaker. So essentially the community, for example, Target has implemented OpenStack driver, and Lookout has implemented ECS for Amazon. So it's a very active community in Vibrant. So just to touch on core principles of Spinnaker, with the microservices, and the primary thing that we are trying to do is increase the velocity of delivering the software to end users. You do that by incremental updates, and at the same time, you want to use the immutable infrastructure. Essentially, the component that is built, that is tested, is the same component that goes to the production. So that gives us a consistency in deploying. This includes configuration. Essentially, the configuration approach that you would take, you don't want to rebuild the component that you are deploying in production that is tested differently. And because of this incremental changes and in immutable infrastructure, you can roll back to the previous version. So when you do a rollback, you want to be rolling back not just the bits, binaries, but also the configuration that goes with it. So you build the deployment strategies into it. The primary goal is also to automate all of this, so there are no errors that are introduced on a day-to-day basis. So this repeatability and tracking allows for lower risk of deployments. And last but not least is operational integration. So the operations team and the developer team should have a visibility into what is going into the operations, when it's going, what's changed, and what are the checks that are done before it goes into it. A brief overview of Spinnaker architecture. Spinnaker itself is built with the microservices architecture, and each of these components scales horizontally. And you could use only a subset of the components if need be for certain applications. And it is supported with the zero downtime releases. So here are the components. Some of these components are horizontally scaled, and you can size them vertically also for efficiency depending on the deployments. They're both distributed and local in the sense they work with OpenShift environments, AWS, Ubuntu environments, or distributed in Ubuntu. And they support zero downtime upgrades with a tool called Halyard in multiple environments. It has a first-class citizen support for Kubernetes. So there are two methods it supports. The manifest files are natively supported. It treats them as templates, and with the triggers, it has this ability to understand the changed artifacts and construct these manifest files with the changed artifacts and apply them, and make sure the levels are reached within the Kubernetes OpenShift environments before it moves to the next stage. It supports all the native Kubernetes or OpenShift deployment strategies. For the developers who are starting up with containers and not familiar with OpenShift, they could also use a simpler deployment pipeline stages where they can just specify what container ID they want to use and say the service ports that need to open and use that to just deploy. The help start support is already there in Spinnaker. And for people who don't know, Istio is a a service mesh initiative with the Cloud Native Foundation, and that's a network layer service distribution, service mesh basically. It supports both L4 and L7 load balancing for the services. It has intelligent controls on, let's say, incoming traffic. We only want the Chrome browsers to go to the newer version, and the rest of it all goes to the older version. So you can set selectors in similar ways. So this will be integrated in the deployment strategies, the one that we were talking about in terms of Canary. You can use these Istio as part of that strategy to deploy newer versions, verify in an automated way before going full-fledged with the newer version in the production. To give a brief overview of the features of Spinnaker in how it looks, you can see that this is the pipeline view. Each of these stages are represented in the pipeline. Say there is a trigger from a Docker repository, which gets deployed into staging environment. There is a test, and then the production. So they will all be individual stages that can be visually created. And these can also be codified as templates. And any new service that we are deploying, we could select a particular template that matches the strategy and change the parameters and create a pipeline with it. It allows for very flexible stage executions. So you can conditionally test a particular, say, run a particular test or not. There are some things called pipeline expressions. Based on the execution context, you have these variables that are available to you. You can use those variables, set conditions, and allow a particular stage to run or not. Right? There are deployment windows. Essentially, if you're going to production, and you can say, I only want to deploy between 9 and 11 a.m. on Monday morning. You would do that. The reason people tend to do deployments at the high traffic time is it's easier to test the canary at the time and make sure nothing goes wrong in those periods for 5% of the traffic, and can roll back quickly instead of deploying on Sunday night when there's little traffic and get into trouble on Monday morning. So it also supports multiple cloud environments, as we discussed. These are all the drivers that are built in. Essentially, you say deploy stage, pick a target environment and say deploy. And we talked briefly about this blue, green, and canary.
One quick comment I want to make on the previous slide, which is about the deployment, I guess, the various deployment environments. And we actually enabled, we are the first vendor, or first people in the community actually, to enable OpenShift with Spinnaker. If you go to Spinnaker.io, you would not see OpenShift in there. We're trying to get it added there, but essentially we have enabled, we use the Kubernetes APIs that was there, and then we essentially enabled OpenShift to be deployed by Spinnaker. Deployed OpenShift.
Right. We contributed to Spinnaker to have the Spinnaker itself run in OpenShift environment with the security requirements of the enterprise that enforced by OpenShift. Deployment strategies, and then pipeline as a code. In Spinnaker, there's the APIs. Each one of these stages, it's the pipeline itself is codified. So it is possible for us to create a pipeline structure outside and apply it. So in an enterprise, if there are best practices with these templates, they can be applied from outside, as well as you create visually a pipeline and take that and construct a template out of it. There are multiple integrations, and they're always growing. The triggers from CI systems, Docker registry, and it's also possible to trigger one pipeline from another. This is useful when you have the dependent services which are not API compatible, let's say. if you have a certain version, v3.2 only works with v1.0 and above of another service, you can have a pipeline dependencies that goes and checks those dependencies and deploys them. In the notifications again, it's integrated with Slack also, HipChat, SMS. And with any of these events, this can be sent out. If the deployment fails, that's most of the cases, you send out a event, someone can come and take a look. This is one of those popular ones with Netflix. They have the Simin Army, which allows for testing of resiliency in the production environment. The Spinnaker is tightly integrated with Chaos Monkey. Chaos Monkey is a tool which would randomly go terminate certain instances or clusters in the target environment, and you can then attach a automated canary kind of analysis with it. Whenever there's an instance that goes down, you do the analysis and verify your system is up and running as expected. And you can also find the differences in performance when those things happen. You can also have a flexible configuration here to say, in one day, do not delete more than one instance in this particular cluster, or exclude certain clusters. All of this is configurable through the Spinnaker UI that's integrated with Chaos Monkey. And so this is a configuration of a pipeline that you can see in Spinnaker. For resiliency or high availability, an application is deployed, let's say, in multiple regions. Typically, you would deploy it to region 1. After everything is up and running with the newer version, you go deploy to region 2 and cascade to multiple locations for that application. So Spinnaker very easily supports those kind of deployments visually, and you can see how the progression of deployment is going on across different regions. To quickly show the features of the Spinnaker, so this is the Spinnaker interface. Here we have multiple services that are being deployed. In this pipeline, there is a trigger configuration that is coming from Bitbucket, which builds a project and then deploys to staging. Here, one of the interesting things here is the staging itself. This is a pipeline stage. Essentially, it is saying, after this is built, I want to deploy to the staging using a different pipeline. So this actually goes and instantiates this pipeline. After that, there is a manual judgment, and then it deploys to production. This can be triggered by change in code, and this is also using manifest files. So, for example, we saw that it was doing the Highlander. You see the pipeline itself, it's taking an artifact that is built by the Jenkins and then deploying it to this account, K2V8 account. So what it's doing is it's taking the manifest file that's in here in the staging environment. It's a fairly simple manifest file that's doing a recreate strategy because it's a testing environment, and applying the artifact. So here you can see that the version is not specified. After the build is done, when the artifact ID is specified in the Jenkins properties file, the Spinnaker has this ability to pick up the new artifacts that are created and apply them to the pipelines and deploy to OpenShift environment. And so this one is a configuration where it's not using manifest files. it's a very similar configuration, but without using manifest files. Here you can see the strategy is Highlander, but in production, the strategy is red black. In Netflix terminology, they use the terminology of red black, which is also commonly used as blue green. Here you can see that the developers can select the containers of production ops and the load balancer and configure the basic settings here. So like you can specify the ports, volumes, probes, and you can leave them alone, and that's it. And you say red black, and Spinnaker automatically brings up a new replica set with a newer version and switches the load balancer or service to it, and creates the red-black deployment strategy with OpenShift. So here in the OpenShift, we can see this staging environment. So the pipelines that are deploying, they're deploying to two different projects. In OpenShift environment, the projects essentially are the same as the namespaces. So here we have a production namespace. There are two applications that are being deployed here. When using the replica set directly without the deployment, you would get replica set v1 clusters that are built in, and you can see them under the infrastructure in single view in Spinnaker. So these are the ones that are deployed through manifest, and in the production environment, this is essentially what we saw in the UI. Here you can see the number of pods that are running, what the cluster is, its operations that we can do. The services also are displayed here in this cluster. This is a cluster that's attached to this load balancer. And similarly, the services that are deployed through manifest are also available in this view. So it gives you a consistent view of all the applications and services deployed as part of this application and services that are grouped as part of the pipeline. So one other thing is this manual judgment is essentially waiting for someone to come in and say yes or no. Maybe we can just trigger off one of the pipelines and just do. While that is running, we can see that there is execution windows that we can specify for it, deployments. And there are conditional expressions that we can enter. If in the trigger, if the data is coming in from, let's say, Jenkins, and the build is done through dev and not through production, through the master, then we can check that the trigger dot build dot sorry, I'm blanking out. Can do something like dev. Then, sorry, this is master. Only then it would go deploy to this production. We can also specify the restriction of windows. We can specify select Monday and the times and allow it to deploy there. I'm not saving that for now. The pipeline is running. Once this build is done, when it deploys, we will see, right now it's done with the build, it's doing the staging deploy. In OpenShift environment, we will we will see that there is a new replica set that gets created. And once this is done, we'll see that replica set. So this, again, we said this stage itself is a pipeline stage. So we can see that this stage is running. It's actually triggered this pipeline. And when the pipeline is complete, you can have this manual stage. You say continue because we like the deployment, and it continues. So there's a new replica set that got created, and it's healthy. There you go. So now it's, we said it's good with the staging. Now it's going to the production. And one other thing with the triggers, you can have multiple types of triggers, and there is RBAC built in. You can have secret keys that come in with it. You can have webhooks with any third-party integration that is done. I think we're close to running out of time. I'll quickly show what it means there. This is the automated canary analysis. We can specify what is the baseline version that we want to check with, and every time the new version is deployed, it verifies the canary of that system, and this is the report that you would get with the canary analysis. If you can specify thresholds for the score where it allows moving to production or not. We're close to running out of time, so Balaji, you want to continue?
Yeah, so I think there was also a question actually that I was answering, which is obviously Spinnaker is open source, and so there's a need for enterprises to have some sort of support that helps them to deploy to production in case there's issues that pop up, or generally you hit a bug and you want to drive through the community, et cetera, et cetera. So there's also aspect to how to onboard applications, how to onboard users. So OpsMx, this is sort of the advertisement part, I guess, of this presentation. We actually provide enterprise Spinnaker for users. So we obviously support the open source Spinnaker. So we have a community version where we support people who want to use the open source. But most enterprises need 24/7 support or for enterprise support. And so they want to also, we also provide additional features on top of Spinnaker. It's fully, Spinnaker is open source, and we provide this additional things on top of it, like on easy onboarding, like the automated verification that Gopi talked about, where we're able to use logs, APM metrics, and other kinds of metrics that you have, like Datadog, New Relic, Splunk, et cetera, to be able to do a smart deploy. So you deploy rollouts. Today is just a basic health check that you do on top of when Kubernetes rolls out an application. You don't really test the actual application itself, whether it is actually is good or not. Does it have any regressions? And does it still meet the SLAs, et cetera, et cetera? So you want to be able to, people do it today manually. They check the few APIs and see if it's okay. What we've done is we've created an automated way to look at it. We also use machine learning so that what it checks is automatically updated all the time. So these are some of the value add we do as part of the enterprise Spinnaker. Things around security. So you want to be able to do LDAP, RBAC, and things around audit and compliance for enterprises. Spinnaker, as we talked about, has 100% APIs for all the events that is registering in terms of who deployed, what they deployed, and when it was deployed, who approved it, et cetera, et cetera. But there's no sort of an easy way to sort of productionize that, right? In terms of, if you have an auditor who comes in and says, show me this, you need to write your own script, for example, to find that information. So some of the things we do, and compliance is another thing. People have rules around compliance. You shall not, dev shall not deploy to production, or this needs to be in place to deploy this application to production environments. They can't go to AWS, they can't go to Europe zone, whatever, et cetera, et cetera. And as a developer, you may make a mistake, or somebody who's setting up the pipeline, you may make a mistake, but these things will essentially audit that and verify that those things are there. So we have integration into various data sources, obviously the logs, metrics, and APM data sources, but also data sources. Can you go back to, sorry, data sources around security verification, SAST, and DAST tools, etc. as well, around to do security and verifications. The other part around deployment environments that we talked about already, that Spinnaker obviously provides a set of deployment options, like called the cloud drivers. Obviously the things around AWS, Kubernetes, etc., etc. And what we do is we enable the OpenShift, basically a customer requirement, asking us to say, OpenShift is not there. How can we enable Spinnaker to deploy to OpenShift? And I have a multi-tenancy. I have these requirements, enterprise requirements that we have on our OpenShift cluster. I want to make sure that Spinnaker actually be able to work within that environments, and that's something we did. That's a lot of effort that we put in to make that work, and we're happy to share with the community and to other customers. And there was also other environments like OpenStack, for example. Even though it's supported, Target actually created that feature, actually contributed the code. There's still some gaps in the way it is implemented for somebody who's not using exactly the same way Target is using, for example. Or you have a newer version that something changed, for example. Those things where we come in and really do a good job of helping customers. I think AWS is fully baked, I would say, on the Spinnaker. The Kubernetes is pretty close to being fully baked, but there are other provider environments where there's a lot of gaps, and we definitely put into that. We have customers asking us about vSphere. I have vSphere. I want to deploy to vSphere. So these are some of the things we provide as part of Enterprise Spinnaker, and we have customers, for example, want to use Spinnaker to deploy to multiple instances of Spinnaker itself. Like, I want to be able to deploy to multiple groups, or I want to have multiple Spinnaker deployments, and I want to build manage that. So these are some of the things we do. So next slide, please. Yeah, I think we talked about this a little bit already, the ability to deploy verification, basically using the automated verification feature, be able to do smart deploys, right? Able to roll back, be intelligent to be able to control your rollouts, and using data and using machine learning and data. And compliance is something an enterprise level feature. Next slide. I think you already covered it. You want to take a couple of minutes to go through that, one of the reports maybe of the verification thing, Gopi?
Okay, yeah, sure. So in the verification, you can specify what do you want to verify. So it can be the logs or APM metrics. So for example, in this particular case, the score is low. Usually we have a threshold somewhere like around 85, above which it's a successful comparison between the versions, and below is a failure. In this particular case, it's identified going through the logs. We use NLP with RNN processing, and it identified the differences, and there are some error topics that were generated in the newer one that did not exist in the previous version. So if there are topics that have consistent warnings or errors in version 1 and in the newer version, then it would not highlight that. Here there were significant reconnects that were happening in the second version that it picked out and shown that. So these are the APM metrics. Based on the SLAs and SLOs, you can specify what you want to check, and it automatically goes and verifies each one of those groups and identifies which one also are important for this particular deployment over a long period. So it learns essentially to identify if you're collecting both the infrastructure metrics as well as the service level metrics. It identifies which ones are the ones that are important, which ones are not, and weighs them automatically for you. So it identifies that these are the dimensions in which the system has differed and identifies if that's a failure condition or not.
Just to reiterate, right? This is a report that gets auto-generated as part of the pipeline. So when I think Gopi showed in the Spinnaker UI, as part of the stage, if you go back to the run report, go to the run site. I'm sorry. So you basically, this stage is automatically set up as part of every pipeline run, for example. If the score is below a certain threshold, we can basically program it to stop, because usually you don't want to have a bad release go out, and the users are able to basically figure out from why did the release fail, and then you're able to go to that report and figure out what went on. Okay, that's good for now, Gopi. I think we are out of time, so let's go back to that thing. Okay, yeah, one last slide. Yeah, so there's something called Spinnaker Summit. That is Netflix is a sponsor, and they have set up. They did a one last year, and this year it's happening in Seattle, October 8th through 9th. I think about 40 plus sessions, or on roadmaps, case studies, best practices, etc., etc. And I think the expectation is about 400 to 500 attendees. We have a discount coupon. Discount code. We are one of the sponsors of the Spinnaker Summit. So if you use the OpsMx 20, you get up to 20% off. So please feel free to use it and enjoy the Spinnaker Summit. Next slide, please. I think we are done there. I think, if you have more questions, reach out to us at info@opsmx.com. Obviously, you have the Spinnaker Slack channel that you can use to ask questions to the community. If there's any questions, we can happy to take. I think I'm waiting talking to one Thorsten a little bit. Feel free to email me as well. Go ahead.